So let's look at how to access a TVM solver on the TI calculator. Now, there are TVM solvers that are available for phones, through banks, on Casio calculators. This is not the only way to do it, but this happens to be the calculator that my school uses. So if we go under Apps, that opens up Applications. You may not see all of the things listed that I have, but you will at least have the Finance option on your list, which is the one that we want. And under Finance, we want TVM Solver. Now we open that up, we see a large list, we see PMT at the bottom. Let's take a look at what this all means. So here are all of the selections that you have on the left-hand side, and here's what they mean on the right-hand side and what we're going to be putting into them. So N stands for the total number of payments. You're going to take the number of years that something is invested and multiply by the number of payments that are made on it. And we'll look at payments in a little more detail in the next unit. I is the interest. This is as a percentage. PV is short for the present value. Now, in this unit, we're investing things, so this will be a negative value. PMT, we're going to look at this in the next unit, so we're not going to focus on it right now. PV is the future value, that is your A value in the compound interest calculations. P over Y is payments per year. C over Y is compounding periods per year. Now, on this list, these two in particular have a slightly additional meaning that we'll get to when we get to 1.5. So let's just take a standard TVM solver question and look at how we can solve it by using the TVM solver. So we have Bill invests $6,000 into a GIC, which earns 3.2% compound interest, compounded monthly, for a term of 5 years. How much money will Bill receive from the GIC in 5 years' time? So this is actually similar to a problem that we worked out using the formula in 1.3. Let's see how to solve it using the TVM solver. So we have Bill invests $6,000. So that's the initial investment. That's going to go under PV. And we're going to record that as a negative because we're paying it. So we're investing it at the start. So this is negative, and use the negative symbol to the left of the enter key, not the subtraction. So negative 6,000. And that's going to be the present value. And that's invested into a GIC, which earns 3.2% compound interest. So I is 3.2%. Compounded monthly. So if it's compounded monthly, it's compounded 12 times per year. So we're going to set C over Y to 12. Set P over Y to 12 as well. Sometimes this value will be set to something different, but for these questions where you're just investing money and leaving it in the investment, make sure that P over Y and C over Y are the same. And this is invested for a term of 5 years. So N is the number of years it's invested times the whatever value is in P over Y here. And this is the number of times that our investment is compounded per year. So this is 12. If we just put 5 times 12 here using the multiplication sign, note that it will change it to 60 immediately as I hit enter. Now, what we want to find for this problem is the future value. How much money will Bill receive from the GIC in 5 years? So we highlight the item that we're looking for, which is future value. And we press the alpha key, the green one, which is below the second function key. And then after pressing alpha, press enter. And when we do that, we get our answer. And notice that it will be highlighted slightly on the side here in a little black box to show you that that is the value that you have calculated. So we have $7,039.57 when this is rounded off. These PMT values at the end, just leave them the way they are by default. I'll explain what those mean in a later chapter. Now, for the purposes of showing work, what you're just going to do is take these table values that you see and copy them out. And typically when I do these on assignments and tests for my class, I just have a little grid for them to fill in. If you're doing this on your homework, you'll have to make the grid yourself. But just put the 7 values that were in the TVM solver. To the right-hand side, you're going to put the values that you filled in for them, including the value that was calculated. And then in the end, just write a short sentence about what you actually determined. So how much money will Bill receive from GIC in 5 years? So Bill will receive $7,039.57. Question 2. We have Myra who wants to save money now so that in 3 years' time, she'll have $2,000. She has a savings account which earns 1.1% interest, compounded semi-annually. How much money should she put into the account? So this time we know the future value, and we're trying to determine what the present value is going to be. Okay, let's see how we can use our TVM solver to help us solve this. So Myra wants to have $2,000 in the future. So our future value is $2,000. This is a positive because that's how much we're going to receive from the investment in 3 years' time. The savings account earns 1.1% interest. So interest 1.1. Compounded semi-annually. Semi-annually is 2 times per year. So we're going to get set P over Y and C over Y to 2. Now, this investment was invested for 3 years. And in those 3 years, it was compounded semi-annually. So the end value is going to be 3 times 2. 3 years compounded twice per year. So we're just going to multiply by what's in the P over Y here. That gives us 6. And now what we want to determine is what is the present value. What has to be invested right now to make that happen? So we're going to highlight what we want to solve, PV. We're going to press alpha and enter. And this tells us that she would need to invest $1,935.25 right now at this low interest rate to have $2,000 in 3 years' time. So once again, we're just going to copy our table below the problem to show the values that were filled in to the TVM solver and type in that she needs to invest $1,935.25. Note that the problem put a negative in front of this because this is an investment. We're not going to put a negative in our solution. This is just the amount of money that's being invested for this problem. Final problem. Casey received $8,000 from an inheritance. They want to invest it into a guaranteed investment, which earns 2% interest compounded monthly, until it grows to $9,000. How long does Casey need to invest the money for? So in this case, we have an initial investment and we have a final value. We want to figure out how long does this have to invest for under these conditions to reach that final value. Okay, let's take a look at our TVM solver once more. So the initial investment is $8,000. And Casey wants this investment to grow to $9,000. So note that the PV is a negative because we have to pay that at the start, and the FV is a positive because we receive that money in the end. Now, this is at 2% interest compounded monthly. Compounded monthly, so P over Y and C over Y are set to 12. Interest rate was 2%. We want to figure out how long does this need to be invested for. So we want to find our value of N. So we're going to highlight N with our cursor and then press alpha, enter on the calculator. And we receive 70.73. So I've taken that value and put all the work next to this question. So our answer is Casey needs to invest the money for 70.73 what? Well, keep in mind that our value of n is years times whatever this value is under p over y. So it's years times 12. So what this is it's a value in terms of months. So 70.73 months. Now this will not always be months, but you can look at the unit under p over y. You can look at the value under p over y, and that will indicate what your units would be. If this was a 2, it would be half years. If this was a 1, it would be years. Now, here's the thing. This interest gets put onto the investment every month. So even though it would accumulate what is needed partway through month 70, the interest doesn't actually get compounded or added until the end of the month. So this has to be rounded up to 71. And it will always be rounded up. So if my answer was 70.2, I would round it up to 71 because the interest wouldn't be paid in full until the end of the month. Now, 71 months, if I want this in terms of years and months, we could calculate that pretty quickly. 71 months, there are 12 months in a year. So there are 5 years in those 71 months, and a number of leftover months as well. Now, there's a number of ways that you can calculate these leftover months. You can actually take this decimal value and multiply it by 12, but maybe the easiest thing is 71. Well, the conceptually easiest idea is there's 71 months, 5 years times 12. So if we've taken out 5 years, that's taken out 5 times 12, or 60 months, and that leaves us with 11 months left. So our answer would be 5 years, 11 months. Now, you only have to convert this if your teacher requests it of you, or perhaps in a multiple choice you might have to pick from those answers. So keep in mind that whatever this value of n is will typically need to be rounded up in order to figure out what the final answer to the problem is, because we can't receive the interest until the final payment occurs at the end of each month, or it could be at the end of each year or each week or whatever it is. Okay, that's an introduction to using the TVM solver to solve some problems about compound interest.